Organization. Our discussion of optimal mechanism design will be divided up into three categories, depending on our assumptions about the agent's private values. On one hand, as is typical in economics, we can assume that agents' private values are drawn from a non-prior distribution, the so-called Bayesian approach. Given knowledge of these prior distributions, the Bayesian optimal mechanism is the one that achieves the largest expected profit for these agents, where the expectation is taken over the randomness in the agent's evaluations. In section 13.2, we present the seminal result of Meyerson, showing how to design the optimal, i.e. profit maximizing Bayesian auction given the prior distribution from which bidders' evaluations are drawn. On the other hand, in many cases, determining these prior distributions in advance may not be convenient, reasonable, or even possible. It is particularly difficult to collect priors in small markets where the process of collecting information can seriously impact both the incentives of the agents and the performance of the mechanism. Thus, it is of great interest to understand to what extent we are able to design mechanisms for profit maximization, even when we know every little about bidders' valuations. This approach leads us to the more traditional computer science approach of worst-case analysis. While worst-case analysis could lead to results that are overly pessimistic, we shall see that in many cases we are able to obtain worst-case guarantees that are comparable to the optimal average case guarantees for valuations from known distributions. We begin our exploration of a worst-case analysis in section 13.3, where we survey techniques for approximating the optimal mechanism. We give natural mechanisms that approach optimality on large markets and a general formula for their performance as a function of the market size for small markets. To obtain a theory of optimal mechanisms design without assumptions on the size of the market, we adopt a framework of relative optimality. This is motivated by two key observations. First, as we will explain later, there is no truthful mechanism that is best on every input. Second, in the worst case, all the agents' private values could be zero or negligible, and thus no auction will be able to extract a high profit. In section 13.4, we described techniques for designing auctions that always in worst case return a profit that is within a small constant factor of some profit benchmark evaluated with respect to the agent's true private values. Finally, in section 13.5, we consider procurement settings where the auctioneer is looking to buy a set of goods or services that satisfy certain constraints, e.g. a path or a spanning tree in a graph. Specifically, we consider the problem of designing procurement auctions to minimize the total cost of the auctioneer, i.e. maximize their profit relative to a natural benchmark. We conclude the chapter with a discussion of directions for future research.